Hi, welcome to the Photon Academy once again. In this session, let us see some numericals appeared in the previous IIT examinations. Let us see those one by one. First, let me take up Planck's constant. Planck's constant has the dimension of, that is asking the dimension formula of the Planck's constant. This was the question appeared in the IIT-JEE joint entrance examination conducted by the IIT. Clear? Now, as we know that the Planck's equation is E is equal to h nu, where E is the energy, h is the Planck's constant, nu is the frequency. So he was asking the dimension formula of the Planck's constant h, so E by nu. Clear? Now, E is energy. We know that from the previous classes, energy has dimension formula of ml square T minus 2, and frequency is T minus 1. Hence, on simplification, m L square T minus 1 goes. So, remaining was T minus 1. So, this is the dimension formula for the Planck's constant. Clear? Let us take up the second question. That is, in the formula, x is equal to 3yz square. This was the equation provided to us, where x is capacitance, and z is magnetic induction, respectively. Yeah. Then the dimension of y is, this is the fill up the blank, and this also appeared in the JEE examination. Observe the question carefully. There is a formula given to you. This is the formula given to you. X is equal to 3yz square, and is defining what is x. X is defining as capacitance. Is defining the z. Z is magnetic induction. He says, no. He says the dimension of the y. And how clarity? He says it is in the MKS system. He needs in the MKS system. Okay. He's asking in the MKS system. Let us solve this question. Given equation is x is equal to 3y z square. Now, we need the dimension of the y. So, x by 3 z square. Since this term 3 is a numerical, does not have any dimensions. Hence, dimension formula of y is x by z square. What is x? X is capacitance. And y is z is what? Z is magnetic induction. Magnetic induction whole square. Clear? Now I am simply denoting this capacitance as with some letter, that is y is equal to some letter C, and magnetic induction some letter B. Usual notations. Capacitance by the magnetic induction square. Clear? Now, from the previous classes, we know that the dimension formula of the capacitance C is the capacitance is M minus 1 L minus 2 P square and Q square. Q stands for the charge coulomb. You can express this the current into time also, ampere into time also, but directly here it is coulomb. And where the magnetic induction B is having a dimension formula of M T minus 1 Q minus 1. Here also Q stands for the coulomb, where Q is charge coulomb. So it can also be expressed as current I into T. So you can also have the current is having a dimension of ampere, time is T. You can substitute in place of Q, A into T also. Clear? Now, what does he require? He requires the dimension formula of the Y. Y is what? C by B square. C is what? M minus 1 L minus 2 T square Q square by this M T minus 1 Q minus 1 whole square, this entire square. Here, on simplification, the dimension formula of the Y becomes here M to the power of minus 1 L to the power of minus 2 T square Q square denominator M square T minus 2 Q minus 2. So this becomes M to the power of minus 3 L to the power of -2, T to the power of 4, Q to the power of 4. This is the required dimension of Y. And remember always, whenever you solve any units and dimensions, be careful that previous session, whatever we have solved, please by heart them. Some of them you should by heart, and if you know them directly, you can easily substitute and you can easily arrive at the solution. Clear? So in this case, capacitance dimension formula you should know. Similarly, magnetic induction dimension formula you should know. Then only is very easy to directly substitute and get the solution. Now, let me take up the third one. Equation, third problem, let us see. There is the equation of the state of a real gas is given by it provides an equation that is P plus A by V square into V minus B, which is equal to R into T. Clear? Where P is the pressure, V is the volume, and R is the universal gas constant, T is the temperature. Now, he is asking the dimension of constant A is, where A and B are both are constants. Dimensions both are constant, and this is also JEE previous problem. Okay? Now, before attempting this question, observe this equation. Whenever you get such kind of a question, first you check, is it a dimensionally fit equation or not? That's the first thing. The second thing you have to check is principle of homogeneity. That means in this equation, when you add the terms together, all the terms should possess the same units, then only we can add or subtract. Okay? That means all are having the equality. Okay. Now, in this case, he is asking the dimension formula of the constant A. So I take up the first term, P, pressure, plus A by V square is the first term. I need the dimension formula of the A, constant A. Hence, I equate both the terms because both have the same dimensions. So P is equal to A by V square. So I need the dimension formula of A. So P into V square. So P is the pressure. What is pressure? Force by area. So normal force by area. And V is what? Volume. Volume square. Clear? Now, if I simplify this, so this force is having dimension formula of MLT minus 2. And volume is what? LQ. L cube and volume square L to the power of 6. And this is area. Area is what? L square. L square. So 1 L in the numerator, 1 in the denominator goes out. So final constant he is having M, and this L, 1 L goes and another L goes. So L to the power of 5 T minus 2. This is the required dimension formula for the above. M L to the power of 5 T minus 2. Clear? So in such type of questions, we can equate each term. Why? Because each term is having the same dimension. So equation is following the principle of homogeneity. Hence, we can easily equate them. Clear? So let us take up the other problems in the next session. Oh, you have understood this session well. If you like, please subscribe the video. Thank you for watching.